picking up on you.
Yes, you are. Okay, now it's the time to check to see if our model is properly identified or not. Let me pull that up real quick. Okay, so remember the identification, identified or not, is we want to have degrees of freedom of more than greater than 0. Okay, so if it's degrees of freedom is 0, that's just identified. If you come up with a negative number for degrees of freedom, that's under-identified, which is bad, which means that Amos cannot calculate this SEM for you. But basically, you want degrees of freedom to be greater than 1. So to find degrees of freedom in a SEM model, you take the number of observations minus the number of estimated parameters. This is in the path analysis section above the SEM section. So in case you forget, we got another video on there. But real quick, the number of observations is calculated by the number of indicators. That's how many measured variables, how many rectangles you got. We got 12, times the number of indicators plus 1. So in this model, it's going to be 12 times 13 divided by 2, which comes out to be 78. So in other words, the number of observations is 78. Next step is we got to calculate the number of estimated parameters, which is the number of variances, which is each box and each, got to remember, each box has a little error term with it. So that's what we're counting. It doesn't show here in the picture, but we're going to count this box, this error term, this box, this error term, this box, this error term, all the way around. And then we got to count the number of path coefficients. Those are the arrows between the constructs. And then we got to count the number of covariances, which is the number of exogenous variables, and we only have 1. Okay, so to explain the 4s down here, we have 4 items plus 4 error terms. The next one, 4 items plus 4 error terms. 4 items plus 4 error terms gives us a grand total of 24. There's 1, 2, 3 causal arrows, path coefficients, and 1 exogenous variable. So that's a grand total of 28. So to find the degrees of freedom, we take the number of observations, which is 78. We minus the number of estimated parameters, which is 28. So we have 50 degrees of freedom, which is good, which means this model is over-identified, and therefore you can use Amos to investigate your structural equation modeling. Over-identified.